Imagine driving a fully loaded truck toward a road that does not technically exist for most of the year. There is no asphalt, no concrete, no bridge. For several months, there is not even solid ground beneath the route. There is water. Then winter arrives. The lake freezes. And humans look at it and decide, yes, we should probably drive trucks across that. Not small trucks. Heavy commercial vehicles carrying fuel, construction materials, machinery and supplies into places where conventional roads simply do not reach. And somehow this works. But the strange part is not simply that trucks can drive across frozen lakes. The strange part is everything that has to happen before the first heavy truck is allowed onto the ice. Because an ice road is not just a frozen lake with tire tracks. It is temporary infrastructure. It has to be built, measured, maintained, monitored, loaded carefully, driven differently from a normal highway, and eventually allowed to disappear every year. In Canada's Northwest Territories, winter roads connect remote communities and industrial sites that cannot be reached by ordinary all-season roads. The territorial government says roughly 1,400 kilometers of winter and ice roads are constructed and maintained each year. Some cross frozen lakes and rivers. Others cross snow-covered land and trails. Their opening dates depend directly on weather and ice conditions. And one of the most famous examples is the Tibbet to Contwoyto Winter Road. It begins northeast of Yellowknife and pushes deep into the Canadian North, serving remote mine sites. Depending on the season and route, the Northwest Territories government describes it as roughly 400 to 600 kilometers of groomed frozen lakes and portages, and it may only be useful for about 6 to 8 winter weeks. A road hundreds of kilometers long, with an expiration date. Which raises the obvious question, how do you build a highway? When your construction material is winter? The first thing to understand is that cold weather does not automatically create a truck road. A frozen lake can look extremely convincing. It is white, it is solid, you can stand on it, possibly skate on it, perhaps drive a snowmobile over it. None of that means you should immediately place an enormous loaded truck on top. Ice has to become thick enough and strong enough for the load it is expected to carry. So the road begins before heavy trucks ever arrive. Construction crews go out while conditions are still severe. According to the Northwest Territories Department of Infrastructure, winter road construction can begin in November in temperatures below -20 to -40 degrees Celsius, often with very limited daylight. And oddly enough, one of the enemies is snow, which seems unfair. You would assume that if you are trying to build a winter road, snow would be participating constructively. It is winter-themed, but snow can insulate the ice. A thick blanket of snow slows the loss of heat from the water beneath. That can slow ice growth. So crews clear snow from lakes and road alignments, specifically to help the ice thicken faster. Think about what humans are doing here. We are removing winter, so that winter can become more winter. This is already becoming engineering. And early in the season, the equipment itself has to respect the fact that the road is not ready yet. Crews can use lightweight tracked vehicles capable of moving over thinner ice. The heavier equipment comes later. Ice thickness is monitored. The Northwest Territories says crews use technologies including ground-penetrating radar to measure conditions along these roads. And when natural freezing is not giving you enough road quickly enough, humans have another solution. Add more lake. Crews can use a process, commonly called flooding. Water is pumped onto the existing frozen surface. That water freezes. Another layer is added, then perhaps another. You are essentially manufacturing additional road thickness out of the lake itself. This is one of those oddly possible systems that sounds completely normal once someone explains it, and completely absurd if you describe it accurately. We needed a stronger road, so we poured more lake on it. Perfectly reasonable. Apparently, eventually the ice becomes strong enough for traffic. But now we arrive at the part where a truck driver has to forget some of the instincts that work perfectly well on ordinary roads. For example, speed. On a highway, driving significantly below normal speed can be irritating. On certain ice roads, it can be structural engineering. The government of Manitoba, which also operates an extensive seasonal winter road network, recommends that vehicles weighing 7 tons or more travel no faster than 15 kilometers per hour on ice roads. 15. A person on a reasonably motivated bicycle may begin to have opinions, but the speed restriction exists for an extremely interesting reason. A moving heavy vehicle does not simply push vertically down on the ice. The ice sits on water. As the truck moves, it can deform the floating ice sheet and create movement in the water beneath it. Government guidance warns that excessive speed can contribute to wave action, cracking, ice pop-outs, and even complete ice failure. Near shorelines, the interaction can become particularly important because the wave generated beneath the ice can rebound, which means one of the strangest driving rules imaginable is true. Sometimes driving faster makes the road beneath you behave more like water, because, technically, it still is. The road is floating. This changes the psychology of speed completely. On a normal highway, the road exists independently of you. You are simply using it. On an ice road, your vehicle is interacting with the structure carrying it. The truck is part of the problem the road has to solve. And weight creates another set of rules. Road authorities publish load restrictions based on current conditions. Those restrictions can change during the season as ice develops or deteriorates. A route that can handle one class of vehicle today may have different restrictions later. The road is not a fixed object. Its strength changes with weather, and one truck is different from several trucks. Manitoba's official heavy traffic guidance says heavy vehicles traveling in the same direction on ice roads should be staggered roughly 1 kilometer apart, not one car length, not 20 meters, 1 kilometer, because you do not want several enormous loads concentrating stress on the same portion of floating ice, and stopping creates another problem. A moving truck distributes its load through changing sections of the road. A parked truck keeps pressing on one place. So Manitoba specifically prohibits heavy trucks from stopping, parking, unloading or storing freight on ice sections. Loading and unloading should happen on land. Imagine explaining that rule anywhere else. You cannot park here. Why? The parking lot may eventually become a lake. Fair enough. And this is where the entire subject becomes more interesting than the phrase ice road trucker suggests. The driver is not simply someone brave enough to drive over ice. The driver is operating inside a moving engineering, calculation, weight, spacing, speed, temperature, ice condition, visibility, shoreline geometry, road status. The truck is not independent from the environment. Every decision interacts with it. And if you enjoy seeing the hidden systems that make human life function in places where normal rules stop working, subscribe, because frozen highways are only getting stranger. Consider temperature. Cold is obviously necessary, but cold is not one condition. -10, -20, -30, -40. These are very different environments for people, machines, and ice, and both ends of the temperature problem can create complications. Mild weather can soften surfaces and reduce road quality. The Northwest Territories warns that warmer temperatures can make roads deteriorate earlier. Manitoba goes even further in its winter road permit conditions. Travel is not permitted at temperatures of -5 Celsius or warmer under those conditions, and its guidance warns that water on an ice road can erode the travel surface and reduce ice thickness. As spring approaches, ice can change texture. It can lose load-bearing quality. The road does not suddenly receive a calendar notification saying, "Winter is complete. Please close, conditions are monitored, restrictions change, sections close, and eventually the seasonal system ends." But extreme cold is not simply a free advantage either. Humans still have to work in it. Machines have to start, hydraulic systems have to function, batteries have to survive, fuel has to flow. People have to leave warm vehicles to inspect or repair things. The Northwest Territories notes that extreme cold itself can affect equipment, workers, construction schedules, and opening dates, so the road exists inside a surprisingly narrow compromise. cold enough to create infrastructure, but still manageable enough for humans and machines to operate that infrastructure. Then there is visibility. A lake is flat, which sounds excellent for a road, until blowing snow erases almost everything that tells you where the road is. High winds and drifting snow can quickly reduce visibility on exposed winter and ice roads. And on a frozen lake, there may be very little terrain beside you to provide visual reference. No trees, no buildings, no curb, possibly no obvious difference between road and not road. The Northwest Territories specifically warns that drivers can lose track of the route during reduced visibility. Now add another truck. A heavy vehicle moving through loose snow can create its own cloud behind it. So meeting or passing vehicles becomes something drivers have to approach carefully. Manitoba's guidance warns that swirling snow can reduce visibility dramatically around other vehicles. Again, an ordinary driving problem has been upgraded. Passing someone is not simply, "Can I see the other lane?" It becomes, "Can I identify the road? Can the other driver see me? Are we approaching a weak section? Are we near shore? What is the ice condition? What load is each truck carrying? How much space are we creating between heavy vehicles?" Everything is connected. And then comes isolation. Because if your truck breaks down on a city highway, you are annoyed. You call someone. You may wait. You may complain about the towing company. Possibly write a review. But if a vehicle stops working on a remote winter road hundreds of kilometers from conventional infrastructure, the vehicle has suddenly become your shelter. The Northwest Territories recommends carrying a winter survival kit with extra fuel, warm clothing, blankets or sleeping bags, food, water, first aid equipment, tools, spare tires, and a two-way radio or satellite phone. Cellular coverage can be limited or non-existent on remote routes. Manitoba gives similar advice and explicitly warns that an unexpected delay, breakdown, or accident in an isolated area can become life-threatening because assistance may take a long time to arrive. Its recommendations include survival equipment, satellite phones, and CB communication. This completely changes what vehicle reliability means. In a city, reliability is convenience. Here, reliability is also habitat. The engine provides mobility, but if something goes wrong, the cab provides protection from the environment. Fuel is not just fuel for transportation. It may also mean heat. A truck is therefore several things at once: cargo transport, communication point, shelter, heat source, emergency equipment container, and possibly the most visible object rescuers can find in a white landscape, which is why official guidance recommends staying with the vehicle if stranded. You are not merely transporting cargo through winter. You are carrying a small survival system through it. Communication becomes another piece of the road. Some Northwest Territories winter roads have limited or non-existent cellular coverage. On the Mackenzie Valley Winter Road, commercial drivers are told to use radio communication and call out their direction of travel at bridges and major hills. That sounds like a small operational detail. It is not. Because once again, something cities give us almost invisibly has to be deliberately rebuilt. Awareness. On an ordinary highway, painted lanes, signs, mirrors, intersections, traffic lights, cell networks, and emergency services create layers of information around you. On a remote seasonal route, some of those layers are thinner, so radio fills part of the gap. Drivers announce movement. Conditions are reported. Authorities update road status. Routes may close suddenly. Weight restrictions may change. Before a driver leaves, they are encouraged to check road and weather conditions and tell someone the planned route and expected arrival time. In other words, even the fact that you are going somewhere becomes infrastructure. Someone should know, because the road itself may not be there in a few months, and help may not be nearby today. But the reason these roads exist is perhaps the most important part. They are not built because driving over lakes is entertaining. They exist because northern geography makes conventional transportation extraordinarily difficult. The Northwest Territories describes its winter roads as lifelines connecting remote communities to essential supplies and travel routes. They carry fuel used for electricity generation, heating and transportation, as well as dry goods and construction material. Without the seasonal roads, many of those supplies would have to be flown in at far greater cost. Manitoba describes its own winter roads in almost the same way. Temporary routes allow isolated northern communities to receive fuel, food, building material, machinery, and other supplies, sometimes providing access to goods needed for much of the coming year. And the Tibet to Contwoyto Road takes this temporary logic into industrial scale. Remote mine sites in the Arctic need large quantities of fuel, machinery, and supplies. Flying everything is impractical or enormously expensive. So for a short period each winter, the frozen landscape becomes a logistics corridor. The Northwest Territories says this particular road can operate for only 6 to 8 weeks, during which trucks move the large-scale equipment and supplies needed by remote mine operations. This means the season is not simply a winter driving season, it is a window. And the window closes. Every load that crosses during those weeks is moving through infrastructure that has a countdown built into its existence. You cannot repair it in July. There is nothing to repair. The road has become water again, and that creates a strange reversal of how we normally think about weather. For most infrastructure, winter is the enemy. Snow closes airports, ice damages roads, cold breaks pipes, storms slow traffic. Municipalities spend enormous amounts of effort trying to stop winter from interfering with transportation. Here, winter is transportation. The freezing itself creates access. The cold that makes normal roads difficult makes these roads possible. And spring, the season usually associated with easier travel, destroys them. The road begins dying when the weather improves. That may be the most oddly possible thing about it. The safest season for the infrastructure is the one humans generally consider the most hostile. By late winter, crews continue watching conditions: ice thickness, cracks, snow, temperature, road surface, loads. The Northwest Territories says maintenance crews clear drifts, repair cracks, and continually monitor ice thickness through the season. Heavy snowfall can delay ice formation because it insulates the surface. Warm weather can shorten the road's usable life. Eventually, the calculation changes. The road is no longer strong enough for the traffic being asked to use it. Restrictions increase. Sections close. Signs go up. And one of the most unusual highways on Earth stops being a highway. There is no demolition crew, no asphalt removal, no abandoned bridge. The sun handles the decommissioning. Ice softens, snow disappears, water returns. And if you came back months later, you could cross the same location in a boat. This may be the only road where fish can eventually occupy the passing lane. Then the following winter, humans do it again. Snow is cleared. Ice thickens. Measurements begin. Light equipment goes out. Water is pumped onto surfaces where more thickness is needed. Routes are inspected. Weight limits rise as conditions allow, and eventually heavy trucks return. A transportation network reappears on top of lakes and rivers, not because the landscape permanently changed, but because for a few weeks, the physics became useful. And that is what makes ice roads so interesting. They are not really examples of humans defeating nature. Nobody defeats winter here. The entire system works because humans cooperate with a very specific temporary version of it. Too warm, and the road disappears. Too much, snow, and ice growth can slow. Drive too fast, and the truck can create dangerous movement beneath the surface. Put too much weight in one place, and the structure may fail, lose communication, and isolation becomes much more serious. Breakdown, and the truck becomes shelter. Every part of the system is a negotiation. So when you see a photograph of an enormous truck driving across a frozen lake, the impressive part is not that the driver is simply brave enough to press the Accelerator. The impressive part is everything you cannot see. People measured that ice. People cleared the snow. People monitored the weather. People established load restrictions. People maintained the route. The driver controls speed in ways that protect the structure beneath the wheels. Other trucks keep their distance. Communication systems compensate for isolation. Emergency equipment waits inside the cab. And somewhere, somebody is watching the calendar, because the road has an expiration date. A winter road is not just a road built on ice. It is a transportation system built out of temperature. And for a few weeks every year, humans turn winter itself into infrastructure. Then spring arrives, and the highway becomes a lake again.